Hello, friends. Welcome back, and thank you once again for linking up and tuning in. And I want us to continue with the calculation of or the approximation of area. Um, if you remember in the previous clip, if you have checked, we looked at approximation of area using the mid-ordinate rule. In this clip, I want us to look at, again, considering the same curve as we did in the previous case, how to find the area, to estimate the area under the curve by another rule here, what we call the trapezium rule. Some people refer to it as the trapezoidal rule. So as the question reads, you can see use the trapezium rule to estimate the area enclosed by the curve y is equal to negative x squared plus 2x plus 8, the x-axis, and the y-axis, sorry, and the x-axis using 4 strips. So to do this, just like I'd said even in the previous case, first of all, you need to do a sketch of the curve so that we know exactly, we visualize exactly the area that we are being asked for here. It is always advisable to do a sketch. I challenge you to check if you haven't checked. There are one of my previous clips where I took you through the process of sketching a curve. So in this case, if you do a sketch of what we have here, you'll realize that it's a curve that passes through. The y-intercept is at 8. One of the x-intercepts is at negative 2. The turning point is at around 1, 9. So if that is this, consider that to be 9. Then down here is 1. Then let's say 2, 3. Then for the other x-intercept is at 4. So if you do a sketch, remember a sketch is to give you a rough idea. It might not be very accurate. In fact, it's not expected to be very accurate because of what it is, just a sketch. Okay. So if you draw something like this, so it should be something like this, a curve like this, a sketch, so that we have 1, 2, 3, and 4. So according to that question, the area we're being asked for is what is shaded here. Now we have to use 4 strips. So from here you can see would have this, the first strip will be at that place, and the next strip will be here, and we have here, you can see 1, 2, 3, 4 strips. Okay. By trapezium rule, once we have this, of course, these strips, when you connect their tops with the straight lines, you'll get trapezia, and that's why we're calling that rule a trapezium rule. So we need to know these sides, the edges, the length of the edges, and then we'll find the area of each of the trapezia, and then the sum will be the area that is required in this case. So what we need to know are these dimensions. So let's call the first one y0, then y1, y2, y3, and then the very last one will be y4 at the very last here. So in other words, in short, what we need to find these dimensions. So to do that, we can form a table. So you can see here, the y0 will be determined by the value of x here. Y1 will be determined by the value of x here, which is 1, and then 2, y2, y3, and y4 respectively by the respective values of x that we have here. So we'll start with x at 0, then x at 1, 2, 3, and 4. And these corresponding y values are obtained by substituting the x values in the function. Substituting the x values in the function. So if you substitute appropriately, when x is 0, you'll have y is 8. When x is 1, your value of y is 9. When x is 2, you have 8. When x is 3, you'll get 5. I challenge you, can you do that? Do the substitution to confirm. And when x is 4, even as you can see from here, the value of y is 0. So this will give us the y nodes, the y1, y2, y3, y4. After knowing that, now we come and apply. Okay, I said that these are to help us find the areas of each of the trapezia, the sum of which will give us the area that is required here. Which is true, but that now has been condensed into a formula, which in a short while I'll show you here. Now remember that each of the trapezia have the same height or width, okay, like this. So that is normally a rule of thumb, like when you're using either coordinate rule or trapezium rule, the strips that you use must be of equal width. So when we have trapezium rule, and you can check this in your mathematical tables, the formula is given by a half of h being the width of the trapezia or the strips, and then you have a scaling bracket, and then we have two brackets in there. The first bracket has the first y, this one, at the extreme edge, so which we call y naught, and then it also has the last y at the extreme right or the other extreme edge, and then plus the other bracket we have 2 times. Now this starts with y. If here we have y naught and yn, in here in the other bracket we'll have y1 plus y2 all the way up to yn minus 1. Okay, so like in our case here, so to find the area we'll have h, a half h. Our h is 1. You can see the trapezia, the width is 1, each trapezia. So times 1 into y naught plus yn. Our y naught is 8, and our yn, now our n is 4 here. So yn is 4, the last h on this other end. So in the first bracket we'll have 8 plus 0, and then plus 2 into, now the middle, the other y's. So the other y's are y1, y2, and y3. And our y1 is, as you can see, 9, y2 is 8, and y3 is 5. So this substitution, we work it out, and the result will be the area that we are looking for, the estimated area by this method. So this will be half times 1, which is a half, into 8 plus 0, which is 8, plus, now in this bracket we have 8 plus 9, that is 17, 17 plus 5, that is 22, 22 multiplied by 22 multiplied by 2 is 44, so we'll have 44. And you can see this is now a half multiplied, now 8 plus 44 is 52, and that gives you 26 square units. So this is the area that is required according to our question by the trapezium rule. Thank you so much for your audience. I request you, if you haven't subscribed, do subscribe And remember to give me a thumbs up by liking what I have done. Share with your friends, make a comment, just say even good, or if it is bad, you can also make a comment and advise me on what to do and how best to ensure that I present this work in a beneficial manner to you. Please press that bell button so that when I upload a new video, you'll always be notified. Thank you once again for your audience. Bye bye, and always take care.